Hello and welcome. This demonstration covers the installation, configuration, and basic use of the AWS Command Line Interface, or AWS CLI. First, I'll show you how to install the AWS CLI on both Windows and Mac OS. Then, I'll configure the AWS CLI installation to authenticate with an AWS account. Next, I'll run some example commands to verify that the installation and configuration were successful. And finally, I'll show you how to use the profile feature to run commands against different accounts. Let's get started. First, let's review the purpose of the AWS CLI. The first time you ever accessed an AWS account, you probably logged in to the AWS Management Console using a browser. This is a popular way to access an account because it provides a graphical user interface. However, on occasion, you might want to interact programmatically with an AWS account by running commands, for example, from a terminal window on your laptop. You can do this with the AWS CLI. To use the AWS CLI, you first need to install it. Let's start by seeing how to do that on a Windows machine. Okay, so here I am on a Windows machine. I've already opened a browser and used a search engine to find the AWS Command Line Interface User Guide, which is hosted on the AWS documentation page. The user guide has step-by-step installation instructions. Notice that two versions of the AWS CLI are available. Version 1 is still supported, but the latest and recommended version is version 2. That's the one I'll install now. The AWS CLI can be installed on Docker, Linux, Mac OS, or Windows. I'll choose Windows. Notice the prerequisites. For example, you need admin rights on the machine where you're installing the AWS CLI. I'll choose the link to install the latest version. That prompts my browser to start downloading the installer package. Now that it's finished downloading, I'll open the installer, and the welcome window displays. I'll choose Next. I'll read through and accept the license agreement, and then choose Next. I'll accept the default installation location and choose Next. And finally, I'll choose Install. After it finishes installing, I'll choose Finish. Next, I'll open a command prompt window. And finally, I'll run the command AWS --version to verify the installation. Notice that the response indicates that version 2 of the AWS CLI is installed. Excellent. The software is installed. Next, let's look quickly at how to accomplish these same steps on Mac OS. Okay, so here I am on a Mac OS machine. And just as I did when installing on Windows, I've browsed to the AWS Command Line Interface User Guide. I'll choose the link to install AWS CLI version 2. This time I'll choose Mac OS, and now I'll choose the link to install the latest version. And that prompts my browser to download the installer package. And now that it's finished downloading, I'll open the installer. The welcome window displays. Choose Continue, and then choose Continue again. At the license agreement window, choose Continue again. Read through the license agreement and agree to it. I'll choose to install this for all users on this computer, and then choose Continue again. I'll accept the default installation location, and finally, I'll choose Install. I'm prompted for my OS password to allow the installation, so I'll enter that. After it shows that the installation was successful, choose Close. I'm prompted to move the installer to the trash, which I will do, and next I'll open a terminal window. And finally, just as I did on Windows, I'll run the command AWS --version to verify the installation. And again, notice that the response indicates that version 2 of the AWS CLI is installed. Excellent, the tool is installed. At this point, I need to configure the software so that it can communicate with an AWS account. To accomplish that, I need to have some valid AWS user credentials. So here I am, logged into the AWS Management Console of the account that I want to configure the AWS CLI access to. I need to find my existing credentials or create new credentials, which I can then configure the AWS CLI software to use. Programmatic access is managed through the AWS Identity and Access Management, or IAM service. I'll search for that service in the search bar. Great. So now here I am in the IAM console. I'll select Users and then choose Add Users. I'll give the user the name MyDemoUser. For access type, I'll choose Programmatic Access. That's all I need for the AWS CLI user. And choose Next Permissions. Then I'll choose to attach an existing policy directly. When you assign user permissions, AWS recommends always following the principle of least privilege. I want to use the AWS CLI to list the contents of a bucket in AWS Simple Storage Service or Amazon S3. So I want to assign S3 read-only permissions to this user, but I won't grant any additional permissions. In the filter box, I'll filter for existing S3 service policies. And I'll choose the Amazon S3 read-only access policy. I'll choose Next Tags and then Next Review, and finally I'll choose Create User. The user has now been created. Notice that because I granted this user programmatic access, an access key and secret access key were generated. I need to capture these credentials. This is the only time that this secret access key value will be available. The credentials can be downloaded as a CSV file, but for this demo, I'll just copy the credentials from this browser directly into the AWS CLI interface. I'll start by copying the access key ID. Now that I have a set of access credentials, I can configure the AWS CLI. I'll demonstrate this in a terminal on a Windows machine. However, if you are on macOS or another supported platform, the software behaves the same way. To begin, I'll run the AWS configure command. The first value it prompts me for is the AWS access key ID. So I'll paste in the value from the IAM console window and then press enter. Next, it asks for the AWS secret access key. So I'll return to the screen where that exists and copy it. And now I'll return to the terminal and paste that in. Next, the utility asks for the default AWS region to use when running commands. For region, I'll enter US East 1. The console has a complete list of region names and their values. Let's look at where to find that. So here I'll go back to the console, and in the top right area of the window, I'll choose the region menu. It shows the current region as global because I'm in the IAM console, and IAM is a global service. But notice the available options. The US East 1 region that I just set as the default is the Northern Virginia region. The utility now asks for the default output format that the AWS CLI will use to respond to commands. Available formats include JSON and YAML. The other available formats are YAML stream, text, or table. For this demonstration, I'll enter JSON and press enter to complete the configuration. I can now verify that I've configured the AWS CLI correctly. The user account should have read access to Amazon S3. So, for example, I should be able to retrieve a list of buckets in the account. First, I'll show you in the console that an S3 bucket with a file in it does exist. I'll search for S3 and select it to navigate to the Amazon S3 console. And here you see that this account has a bucket. If I choose the bucket name, you see that it contains a single object, a .png file. So if I run the correct AWS CLI command, I should be able to retrieve this information programmatically in the terminal window. You can find information about all of the commands in the AWS CLI command reference document. To find the command for Amazon S3, I'll scroll down to S3. Next, I'll scroll down to find the list of available commands. The ls command looks familiar to me. I'll choose that. The reference tells me that this command lists S3 buckets and their objects, and it gives examples for different scenarios. The first example, which shows listing all user-owned buckets, looks useful. I think I'm ready to try running a command. I'll try running the AWS S3 ls command. The command has a specific structure. It starts with the program name, which is AWS. Next, the command specifies the service to interact with. In this case, it's S3. And the next part of the command specifies the operation to run. This example uses the ls command, which lists buckets and objects in them. Okay, let's run it. Great, it found the bucket. So that's helpful, but what if I want to see the contents of the bucket? I could look back at the documentation, but I can also get help from inside the AWS CLI itself. I'll type AWS S3 ls help. Notice that the output contains the same information that was in the reference document. Excellent. Here I can see that for this ls operation, I could optionally specify an S3 URI. If I scroll down to example 2, it shows an example S3 URI. I just hold down the enter key to scroll through it, and then type Q to quit out of it. I'll use the up arrow on my keyboard to load the last command that I ran, and then add the S3 URI to it, which will be S3://bucket name. After pressing enter, the output shows a list of objects in the S3 bucket. It lists the .png file that we saw earlier in the console. I'd like to cover one more topic in this demonstration, profiles. So far, I've configured this AWS CLI installation to communicate with a single AWS account. However, by using profiles, you can configure it to communicate with multiple accounts. First, let's observe the profile I already created. The configuration information is usually stored in the home directory for the platform you're using, in a directory named .aws. On Windows, I can issue the command more %userprofile%\.aws/credentials to see the stored credentials for each profile. Notice that the credentials I entered earlier are stored in this file. To maintain security, it's important to protect this file from unauthorized access. Notice the first line in the file, which is default, meaning these settings pertain to the default profile. On macOS, you could view this file by running cat://.aws/credentials. I'm not going to run that on this Windows machine, but just know that if you are following along on a macOS or a Linux machine, that's where the file is located. Okay, so regardless of OS, another file in the same directory stores the region and output preferences that I set. That file is named config. Notice here as well that the first line in the file is default. Let's try entering another set of credentials in a new profile. Okay, here I'm logged into a different AWS account, and I've already defined an IAM user and granted them access to the Amazon Elastic Compute Cloud or Amazon EC2 service. I've copied down the access credentials for this user already. Let's open the file and use those values to define a new profile in the AWS CLI installation. I'll copy the access key value, and now I'll return to the terminal and configure the new profile. I'll enter AWS configure --profile second account. I'm prompted for the access key ID, which I'll paste in now. And next, it asks for the AWS secret access key value. I'll copy that and paste it in. For the default AWS region, I'll again use US East 1. Finally, for the default output format, I'll set it to JSON. Let's view the contents of the credentials file again to see how it was updated. I'll run the command more %userprofile%\.aws/credentials to see the stored credentials. Notice that this file now contains credentials for both accounts. Now let's test. The second account should have access to Amazon EC2. I happen to know a command to test that service. I'll run the command AWS EC2 describe regions. I receive a permission denied response. Why? Oh, maybe because I did not specify to use the new profile. The account in the default profile doesn't have EC2 access, so that result makes sense. Let's try that again. AWS EC2 describe regions --profile second account. That's more like it. If I don't specify a profile in the command, it uses the default profile. And that concludes this demonstration of the AWS CLI. Thanks for watching.
Welcome to Module 3, Developing Storage Solutions. Section 1, Introduction. At the end of this module, you should be able to describe how the Amazon Simple Storage Service, or Amazon S3, can be used as a storage solution, identify features and components of S3, describe how to protect data in S3, describe the function of S3 object operations, explain how to manage access to S3 resources, and develop with S3 using the AWS Software Development Kits, or SDKs. This module includes the following sections: Introduction, introducing Amazon S3, creating S3 buckets, working with S3 objects, and protecting data and managing access to S3 resources. Sophia has decided on a development environment, and she's ready to start building. She wants to create a proof of concept website for the cafe without exposing the site to the outside world yet. Sophia plans to use the proof of concept to demonstrate to Frank and Martha how a website could visually showcase the cafe's offerings. This diagram gives an overview of the application you will build through the labs in this course. The highlighted portions are relevant to this module. As highlighted in the diagram, you will host a static website with Amazon S3. The bucket will be protected with a bucket policy to limit the source of request. Thanks for watching. We'll see you in the next video. Section 2, Introducing Amazon S3. Amazon S3 is an object storage service that offers the ability to store large amounts of data. It's designed for 11 nines of durability. That means the service is designed so that if you store 10 million objects in S3, you might lose one object every 10,000 years on average. You can manage S3 in the console or programmatically. You can configure the service with fine-tuned access controls for specific business goals or compliance requirements. You can also configure S3 to generate event notifications. For example, you can configure notifications to be sent when an object is created, deleted, or restored, or when a replication event occurs. The event notification can be sent to other AWS services, such as AWS Lambda, for further processing. As a developer, you can use these features to create event-driven solutions. Amazon S3 can be used in many different scenarios. We'll talk about 5 specific use cases. The first use case is secure content storage and distribution for static content. S3 can store documents, pictures, videos, game updates, and other types of content. You can distribute the content directly from S3 or through Amazon CloudFront. The second use case is as a backup and restore archive. Because it's designed for durability and availability, you can use S3 as a long-term storage solution. The third use case is to create a data lake, which is a centralized repository to store all your structured and unstructured data. S3 has virtually unlimited storage. The fourth use case is disaster recovery, often called DR. You can use S3 to protect critical data, applications, and IT systems running in the AWS cloud or in your on-premises environment without incurring the expense of a second physical site. A fifth use case is to host a static website. On a static website, individual pages include static content and possibly client-side scripts. By contrast, a dynamic website relies on server-side processing. S3 doesn't support server-side scripting. The essential components of Amazon S3 are buckets, objects, and keys. A bucket is a container for objects stored in S3. Buckets organize the S3 namespace at the highest level and identify the account responsible for storage and data transfer charges. They also play a role in access control. An object is the fundamental entity that's stored in S3, and objects are stored in buckets. An object can be any kind of file and is made up of data and metadata. An object key is what uniquely identifies the object in a bucket and is used to reference an object. The top of the slide gives the URL for a bucket. It begins with the region-specific endpoint followed by the bucket name. Note that each bucket is regional, and you can choose the AWS region where your buckets are stored. Objects stored in an AWS region never leave the region unless you explicitly transfer them to another region. The bottom of the slide shows an object URL. It has the same structure as a bucket URL, but the object key value, which is the file name, is added to the end. Here are the key takeaways from this section of the module. Amazon S3 is an object storage service. Some uses for S3 include content storage, backups, data lakes, disaster recovery, and static websites. Objects in an S3 bucket can be referred to by their URL. The key value identifies the object in the bucket. Thanks for watching, and I'll see you in the next video. 3. Creating S3 buckets. When you create a bucket, you must specify its name. You must follow a few rules for bucket names. First, the bucket name must be globally unique. The namespace is shared by all AWS accounts. This means that an existing bucket name can't be used by another AWS account in any AWS region until the bucket is deleted. Next, the name length must be between 3 and 63 characters, and you can only use lowercase letters, numbers, and hyphens in the name. You can't use uppercase characters or underscores. Remember that after you create a bucket, you can't change its name. When you create a bucket, you must also specify the region where the bucket will be hosted. Note that you cannot change a bucket's region. How do you choose the best region? You should consider the latency, cost, and any regulatory requirements for the data in the bucket. You can access objects with virtual host style URLs. The structure starts with the bucket name and a region identifier and ends with the object key. This example has two virtual host style URLs. The first one shows the URL for an object whose key value is cat.jpg. You can see from the URL the name of the bucket is doc-example-bucket. And it's hosted in the EU West 1 region, which is Ireland. The second example shows the URL for a bucket that's configured for static web hosting. Note that the default document isn't specified in the URL. When the bucket is configured for static web hosting, you set the default object. The URL points at the bucket, and the configuration takes care of the rest. Imagine that you had only one folder on a computer to hold every file on that system. That would not be an efficient way to organize your files. For organizational simplicity, Amazon S3 supports the folder concept to group objects. S3 uses prefixes to imply folder structures. In the example, a prefix of 2021/doc-example-bucket/math is used for the John and Maria text files. This prefix gives an implied folder structure. A prefix value is similar to a directory name. Use a prefix to group similar objects together in a bucket. When you programmatically upload objects, you can use prefixes to organize your data. When an S3 bucket is queried, a prefix will limit results to only those objects that begin with the prefix. In the example, the bucket contains objects with student English and math scores for the year 2021. To get all the math score object keys for 2021, specify the prefix 2021/doc-example-bucket/math. A well thought out folder structure can be invaluable to create responsive solutions. Here are the key takeaways for this section of the module. Amazon S3 bucket names are globally unique. Buckets are located in regions, which affects performance and is subject to regulatory requirements. Objects in buckets are referenced through virtual host style URLs. And prefixes imply a folder structure in an S3 bucket. Thanks for watching, and see you in the next video. Section 5, Protecting Data and Managing Access to Amazon S3 Resources. Data protection refers to protecting data while it's in transit as it travels to and from Amazon S3 and while it's at rest when it's stored in Amazon S3. For data in transit, you can use Secure Sockets Layer, known as SSL, or Transport Layer Security, known as TLS. Or you can use client-side encryption. Clients must support TLS version 1.0. AWS recommends TLS version 1.2 or higher. You can encrypt data that's at rest with client-side or server-side encryption. With client-side encryption, you can encrypt data on the client side and upload the encrypted data to S3. You manage the encryption process, encryption keys, and related tools. With server-side encryption, S3 encrypts your data at the object level. It then decrypts the data when it is accessed. 3 options are available, depending on how you choose to manage the encryption keys. The first option uses Amazon S3 Managed Keys, which is referred to as SSE S3. With this option, each object is encrypted with a unique key. The key itself is also encrypted with a root key that is regularly rotated. The second option uses keys managed by the AWS Key Management Service, also called AWS KMS. This option is referred to as SSE KMS and is similar to SSE S3. However, this option has some additional benefits and charges. Using an AWS KMS key requires separate permissions and provides added protection against unauthorized access of your objects in S3. SSE KMS also provides you with an audit trail that show when your KMS key was used and by whom. Additionally, you can create and manage encryption keys yourself, or you can use a default key that is unique to you, the service that you use, and the region. The third option uses customer-provided keys and is referred to as SSEC. With this option, you manage the encryption keys, and S3 manages the encryption as it writes to disk and decryption when you access your objects. Note that S3 will not encrypt objects that are already in the bucket when encryption is enabled. S3 only encrypts objects that are added to the bucket after encryption is enabled. S3 only encrypts objects that are added to the bucket after encryption is enabled. Now that we've covered securing objects, we need to discuss the security of the bucket. You can manage access to your Amazon S3 resources by writing access policies that grant permissions to other users. S3 offers two types of access policies: identity-based policies and resource-based policies. The first type of policy is identity-based policy. Identity-based policies are attached to identities such as users, groups, and roles that are defined in AWS Identity and Access Management, or IAM. Resource-based policies apply to resources. In S3, buckets and objects are the resources. We'll now discuss the different types of resource-based policies. Access Control List, or ACLs, are resource-based policies that manage access to buckets and objects. You can also use them to grant bucket and object permissions to other AWS accounts. When you need to manage objects that aren't owned by the bucket owner, you can use Object ACLs. You can also use them to grant specific permissions for each object in the same bucket. A bucket policy is attached to a bucket and grants permissions to other AWS accounts or IAM users so they can access the bucket and its objects. You can also use bucket policies to manage cross-account access to S3 buckets. The example bucket policy grants anonymous read permissions on all objects in the bucket. The bucket policy has one statement which allows the S3 get object action, which provides read permissions on objects in a bucket named doc-example-bucket. The policy grants anonymous access by specifying the principal with a wildcard, the asterisk character. Pre-signed URLs are useful if you want to allow a user to upload or download a specific object from a bucket without you having to change AWS security credentials or permissions. For example, imagine that you use Amazon S3 to store and share videos. If you have a video in your bucket and both the bucket and the video object are private, you can share the video with other users by creating a pre-signed URL. Pre-signed URLs are generated by using the permissions of whoever creates the URL. Anyone who receives the pre-signed URL can then access the object. Note that the URL applies only to a single object and it has a time limit. When a web page tries to load resources from another domain, the browser will usually block the request. This happens because of checks against cross-origin resource sharing, or CORS. These checks are sometimes referred to as pre-flight checks. You can configure S3 buckets so they have CORS rules that allow them to share resources with other domains. You do this by using a file that's formatted in JSON. This file specifies various information, including the origins you'll allow to access the bucket, which HTTP operations are allowed, and other operation-specific information. You can use Amazon S3 to host static assets, and with CORS, you can share these assets with other websites. You can store web fonts, videos, documents, and other resources in S3, which can then be linked to external websites through CORS. This practice helps you ensure that only specified domains have access. Here are the key takeaways for this section of the module. S3 buckets can be encrypted, and S3 has two types of policies for bucket access: identity-based policies and resource-based policies. Thanks for watching. I'll see you in the next video.